Hello, this is Professor White. We are going to look at roots and radicals using the exponential notation, the exponent notation. Instead of the radical signs, we are going to use exponents. So let's get the basics. When we talk about nth root of a, we write it like that. There is an index here, and it has to indicate a positive integer. Nth root of a is c. I can also write this as a to the 1 over n. So this is the same as this. Okay? Let's look at that. So this notation and this notation are identical. So this is one thing that you need to memorize. What happens when I have an exponent inside the root? Always remember, this one will go outside by the index of that radical. And this one is going to go to the numerator, the inside. But this one is going to go to the radical itself. So I can write it as, I can take the nth power, then take nth root. Or I can do this. Take the nth root and then take the n power. Okay? Sometimes things are a little bit easy when you do that. Let me tell you how this is. For example, let me see. Let's say I want this. You can look at this as that way, which is the same as that way. And from the exponent notations, that may make my life a little easier. You multiply these two, which is that. And you already knew that, but now you know why it is so. Square root of 9 is 3. So you can, show a lot of these things that way. Let's say somebody says, what is this? Let's say I want this. What is 9 to the 3/2? Oh, you might say, what? I don't know. Well, let's look at that. You can write this as square root of 9, right? To the cube. Makes it easier. You know how that works. What is square root of 9? That's 3. And what is 3 cubed? That's 27. Do you see it? So you can actually evaluate these things if you know how to go back and forth between the exponent and radical notation. What happens when my exponent has a negative? Just think of it that it means the exponent does not belong there. So think about it. This is like a to the negative m over n over 1. So this is in the numerator. When you have a negative, it means it should jump to the denominator. It does not belong there. So let's look at this one. It's in the denominator. What does that mean? That means it has to jump to the numerator. Remember, there's a hidden 1 in there. So when you see a negative exponent, always move it to where it belongs. Don't leave it there. That's true also for just regular exponents. Now let's look at a couple of rules, how this works. I know that in a regular exponent, a to the m times a to the n, there is a times thing in here. You add the exponents. Well, how do I do that from the radical notation? What does this mean? You can do it like this. Watch. You can go 4 to the 1/2 times 4 to the 1/3. Okay? So I know 4 to the 1/2, that's 2. 4 to the 1/3 is 2 times, what is that? 4 to the 1/3 is 2 squared to the 3rd power, right? 1/3 power, I'm sorry. So you can write that as 2 times 4 to the 1/3 power. I mean, you can just play with it, but you can actually do a lot of stuff with it. Or you can actually go and like write some like that from here. If you want to write 4 1/2, and then you can say 1/3 and add these up. You can go 4 3 plus 2 over 6. So 4 to the 5/6. You see, I mean, you can do a lot of different things using this rule. Now, what happens with this guy? I kind of got. So if I want to do this, this means 3 to the 1/2 times 3 to the negative 1/4. Do you see that? What I did, I just wrote it like that, and then it is like this. So that means 3 to the 1/2 minus 1/4. So if I go from this notation to exponents, and I go this negative, and then I subtract it. All right, well, another one. What happens when you have an exponent of an exponent? What that means is you can actually go and do a couple of these things. 3 to the 4th power to the 3rd root means 3 to the 4/3, right? And that's to the 5th power. What does that mean? That is going to mean you can multiply this. 3 to the 4 times 5, 20, 20/3. Do you see it? So you can always apply these things to these rules. Let me make sure everything is in here. What happens when the index is the same? Look, 2 to the 1/2, 3 to the 1/2. So in other words, these indices are the same. Can you put them together? Absolutely. Watch. You can put these two together with this rule. So that is 6 to the 1/2. All right? So be familiar with these 1, 2, 3, 4 rules. And the other one that you need to remember, I just did not put that in here, but I'll just put it in the next phase. The ones with the zeros. So if you have, let's say, 1/3 to the 0th power, you know anything to the 0th power is 1, unless it's 0 to the 0th power, that's undefined. Or you can have 0 to the 1/3 power, and that's always 0. Okay? Remember those two. And also remember how this was, the negative exponents, not with the real ones, but something like this. That one was -4 versus this. That one is +4. So remember those. For example, well, how do I do this thing? The best thing to do is to break the 16 down before you deal with the exponents. What is 16? It's 4 times 4, but break it down more. It is 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. So break this number down with your prime factorization. Remember how prime factorization was. 2, 8, 2, 4, 2, 2. This is an easy number. You don't have to do it, but it is a good method. So I can write 16 as 2 to the 4th power. And guess what I need to do after that? I have exponent of an exponent. It will make my life a little easier to deal with. Watch. 2 to the 4 over 1 times 3 over 4. Guess what happened? These two went away. You ended up with 2 to the 3rd, which is 8. Well, that made my life a little easier. Well, let's try this one. Just go back and forth between notations. 125, what is that? You can do a couple of things. 2 plus 1, 3 plus 5. So that's not divisible by 3, but it is divisible by 5. Guess what 125 is? It is 5 cubed. So I'll write that. 5 cubed to the 2/3. All right, you have exponent of an exponent. How do you handle exponent of an exponent? You multiply them. What is 3 times 2/3? 3's will go. You'll have 5 squared, which is 25. Do you see it? Very good. Okay, let's do some more. Now, at this point, I'm going to ignore that m can be negative. We are assuming m is positive. Okay? Or in this case, let's even assume m is positive, non-zero. So I can do stuff with it. Assume. Alright, so I'm going to ignore the absolute values to deal with my basic algebra problems. What is that? Write the expression using the exponent notation. That's all they're asking. M to the what? 2 goes on top, 5 goes at the bottom. The index always is in the denominator. What about something a little more complex? What's this mean? M to the 1/2, m to the 1/4. Okay? M to the 1/2, m to the, this doesn't belong here, right? 1/4. Okay? M, 1/2 minus 1/4. Do the same denominator deal. This is 2 over 4 minus 1 over 4. And that gives me m to the 1 over 4. Can you go back to the radical notation? If I'm asked, why not? Alright? So be familiar with using either notations. Okay. Now I'm going to do a problem that is kind of like more complex of a problem. And I'm going to do it 2 different ways. Using radicals and using exponents. The key is clean up the inside the radical or whatever that you're doing first. That really makes it a little easier. So, and also whenever you see a number, just break it down. So I'm going to go with this rule. So I have cube root. I'm going to clean the side. 16, 2 times 2 times 2 times 2, remember? So that's 2 to the 4th. I have an a squared. You know what? I'm going to also move that negative up because I have another a. Then maybe I can deal with that a to the 3rd. Okay, so I move that a up. You have c squared. And you have b cubed at the bottom. I know that I'm keeping it in the radical form. When I have these 3 things, you know, the index, this power, and that power match, that means they can come out. Be careful. This can come out. Again, I'm assuming all the variables are positive. It will come out as 1 over b. Does that make sense? Can 2 to the 4th come out? Yes, some of it. Now, let's look at that. I'm doing this situation. 2 to the 4th is 2, 2, 2, and a 2. These 3 2's are going to come out. And what will be left behind? Just 1, 2. So I group them that way. So it means that 3 of them will come out as 1. And the rest will be staying back. Now let's look what we have. I have 1, 2 behind. I'll deal with the a's in a second. C squared is behind. And b came out. Alright. Now I will deal with the a. I have a to the 5th. What does that mean? Let's look at how a to the 5th works. A to the 5th is a. Remember, 3 of them will come out. And what will be behind? 2 a's. So 3 of them came out as 1. So you have 2a over b. Alright? And then you have a 2 behind, a c squared behind, and what else is behind? 2 of the a's behind. Do you see it? This is as clean as it gets. You don't have to put that many steps in there, but it does work. Now let's do the same problem with the exponents. Like I said, you can go back and forth. So let me move this to the side a little bit, and I'll do the same problem. I will change everything to exponents. 16 is 2 to the 4th. I have a to the 2nd, c to the 2nd. I'll move that a up. And you have b to the cube. And guess what? I'm supposed to take 1/3. Okay, let's look how that works. I'm going to go and pretty much work that in. That will give me 2 to the 4/3 times a to the, you have 2 and 3, so that's 5/3. c to the 2/3. And at the bottom you have b to the 3/3. Does it make sense? All right. I'm going to go to the next page. This is what I have. All right. Now, let's identify the exponents that have fractions that are proper versus improper. There's a way to deal with the improper fractions. Improper meaning numerator is bigger. Numerator is bigger. These are proper. So when they are proper, they don't get out of the radical. But when they are improper, they do. Now, this I know that c 2/3 is going to stay inside my radical, but the other ones are going to come out. So let's look at that. I am going to come here. Okay, so I have b 3/3, that's going to be b. c 2/3, that's going to stay inside the radical. All right? Now I'm going to deal with this 2 4/3. 2 4/3. Watch. Change that improper fraction into a mixed number. 2 and 1 and 1/3. Does it make sense? Which means 2 to the 1 times 2 to the 1/3. Which means 2 cube root of 2. Does it make sense? All right, 2 to the 4/3 became 2 cube root of 2. 2 cube root of 2. Now let's deal with the other one, a to the 5/3, the same way. Okay, a to the 5/3. Change it into a mixed number. A to the 1 and 2/3, which is the same as a to the 1 times a to the 2/3. This one is proper, but this one is a. What does that mean? A came out, and then the 2 stayed behind. Look at that answer. It actually is the same exact answer that you came up with previously. Let's move that down. Do you see this? And I used the exponents to do that one. And you see this? And I did use the radicals to do that. Just pick any one. You're going to be able to do it. All right? Do you want to do one more? So let's try one more. I'll just make one up. Let's say I have this situation. I'm taking 27. I have a squared, b cubed, something easier. And I want to take square root. Okay, so I'm going to do it with the radicals. With the radicals, all you have to do is just group them into groups of whatever. This is supposed to be groups of 2. So watch. 27 is 3 squared times 3. Just break it down. 3 squared is 9 times 3. Okay. A squared is a squared. B squared is, group them into groups of 2. B2 and B1. What comes out? Here's 1. What comes out? Here's 2. What comes out? Here's 3. This will come out as 3. This will come out as A. This will come out as B. What's left behind? 3 and B. Do you like that method? Let's do the same problem with the exponents. Same problem. Now we're going to use exponents. Break everything down, which is 3 to the 3rd power, a to the 2nd power, b to the 3rd power, and you're supposed to take square root. What does this mean? 3 to the 3/2. Work that square root into each one. A to the 2/2 and b to the 3/2. Does it make sense? Okay? Now, change the improper ones into mixed numbers. 3 to the 1 and 1/2. A to the 2/2, that's 1. B to the 1 and 1/2. Then take the whole numbers out. That there's the 3 to the 1, which is 3. A to the 1, which is A. B to the 1, which is B. But then I also have those 3 to the 1/2 and B to the 1/2. Oh, guess what? I have that, and I know that since the indices are the same, I can't put them like that. Okay, and what do I have in front of it? Guess what? I got the same answer. I just did it a little differently.